Alright folks, today we're going to be talking about the volume for cylinders and cones. Okay, so we've seen both of the versions of the formula for volume. Okay, there's area of the base times the height, or last time we talked about if our shape has a point on it, we're going to take 1/3 and then area of the base times the height. We'll be using both of those today. Okay, cylinder, because it doesn't have a point in the shape, it's just area of the base times the height. Cones will need that 1/3 in front. Okay, you'll notice for big B, or area of the base, on both of these shapes, we've got pi r squared because the base on both a cone and a cylinder is a circle. The area of a circle, pi r squared. Okay, so looking on our first one, since it's a cone, we're using that 1/3 to start out with. So V equals 1/3 area of the base times the height. That means we need the area of the base and we need the height of the cone. Okay, area of the base again is pi r squared, so we really need two pieces of the cone, the radius and the height. Okay, well you'll notice on here we do have the radius, we've got the 15, so we can go ahead and find the area of the base. Pi times 15 squared. 15 squared is one of the ones we know, so 225, and tack on that pi. Okay, but you'll see that going up through the middle here, we don't have the height of the cone. Okay, so throw down an x, and we'll need to use Pythagorean theorem to go ahead and solve that. Okay, so we've got x squared plus 15 squared equals 39 squared. Okay, then x squared plus, again, 15 squared is one of those ones we know, 225. Okay, 39 squared is 1,521. Okay, next we need to subtract over the 225, which gives us 1,296. And last thing, we're taking the square root of that answer to get 36. Okay, so x is 36, but for us, that is the height of our cone. Okay, so 36 goes in for h. Now that we've got all of our pieces, we can put it all together. Okay, so V equals 1/3. Then we've got big B, which was our 225 pi, and then times h, which was 36. Okay. Now, when we go do this, since we've got a pi in our answer, what we're going to do is leave that until the very end. We're just going to take the non-pi numbers. So the 1/3, the 225, and the 36 all get multiplied together. So 1/3 times 225 times 36. We get 2,700, and that's just those numbers. We have to tack on the pi on the end. Okay, so just like we did with surface area, there's two versions of this. The exact version includes pi, so 2,700 pi, our label being inches cubed. Okay, or we can go ahead and get the decimal version, which is going to be useful when we're dealing with a word problem. So we could also say it's approximately 8,482.3 inches cubed. Okay, so two versions there. On the next one, this one you'll notice says no base in big capital letters. Okay, but remember, whether or not there's a base on the bottom doesn't affect the volume, because volume's talking about what's going on the inside, not the outside. Okay, so bases don't affect the volume. Okay, we still need to find the area of the base in order to fill in this formula here. Okay, so volume again is 1/3 area of the base times the height. We need big B. We need h. Okay, big B again here is pi r squared. We're given the radius is 18, so pi times 18 squared. Okay, 18 isn't one of those numbers that we know right off the top of our head. Okay, so you're welcome to type that one in. Okay, 324. Pi goes on the end. Okay, don't leave off the pi in your middle problems as well, not just at the very end, because when you're showing your work here, if you forget to put the pi on there, you're likely to do the same thing in your final answer. Okay, and that makes a big difference to the size or the value of the volume. All right, This time you'll notice though, our height going through the middle was given to us, so we don't have to work hard for that. We've got 24. Plugging it all in, we get 1/3. Area of the base was 324 pi, and our height was 24. Again, when we type this in, we're only dealing with the numbers that look like numbers. Okay, so 1/3 times 324 times 24. And then we get 2,592 pi centimeters cubed. Okay. Our approximate version, when we multiply that by pi to get the decimal, is 8,143. And then that 0 stays 0. You can put it on there, or you can just leave it at 8,143 if you want. Okay, so centimeters cubed as well on that one. All right, so that's basically the idea of volume for a cone. Again, it's got that 1/3 in front of the area of the base times the height. Now we're going to put that together with surface area, because again, that's what's going to happen on your test. You will be asked to find both for the shapes. Okay, so for this one, surface area and volume, you'll go back to your cheat sheet. Okay, so if you don't have that out already, pause the video and grab that so we can look at the formulas for the surface area. Okay, surface area is always the lateral area plus some number of bases. On a cone, we only have one base on the very bottom, so it's just plus b. And then we need to take a look at what the lateral area says. Okay, so on your yellow sheet, you should have had 1/2 p. Sorry about that, folks. We want here for the lateral area pi r l for cones. Okay, so then below that, we still need big B in our formula. So we're looking for the radius, we're looking for L, which hopefully you remember is the slant height, and then we need big B. Okay, so if we look at this here, the radius is given to us. We've got 5. Okay, but the slant height is missing. Okay, so I want you to go ahead and put an X there, and then we can solve for that missing piece. So 5 squared plus X squared equal, order matters here, 12 squared equals X squared, there we go. And then we've got 25 plus 144 equals X squared, 169. So then when we take a square root of that, we should get X equals 13. So that's our slant height L. Okay, and then big B, same as we've been doing with volume. Okay, pi r squared will look like pi times the radius squared, or 5 squared, and 25 pi. So all we have to do is put all these things together for our surface area. Okay, lateral area is pi r l, so that looks like pi times the radius 5 times the slant height 13. Okay, again, we're just using the regular numbers, so 5 times 13, 65 pi. And then we're supposed to take that and add it with our base here. So we're supposed to take those and add them together. Okay, so just 65 plus 25 will take care of it for us, and that is 90 with a pi on the end. Okay, so that's our surface area, 90 pi, and then feet squared for area. Okay, if we want our approximate version, we're going to just type that in, 90 times pi, so 282.7. And then we're going to go take care of volume. All right. So for volume, we need 1/3 area of the base times the height. We've got big B from over here is 25 pi, but we need H, the height of the cone. Now the nice thing is on our triangle here they have to give us 2 of the pieces, so we're only going to have to solve for one missing piece. In this case that was the slant height, so our height was given to us, gives us 12. If we put it all together we've got 1/3 times 25 pi then times 12. Okay, so 1/3 times 25 times 12, and we'll tack the pi on the very end. We get 100 pi feet cubed. Okay, when we tack that pi on for the decimal version, we get 314.2 feet cubed. All right. For the next one, okay, this says no base. All right. So that means when we look at our surface area, it's just the lateral area because we don't need to add any bases. Okay, so what I want you to do is pause the video and try to find both the surface area and the volume. Okay, remember this no base is going to affect this, but it doesn't change the volume. You still need the area of the base to take care of that second part. Okay, so pause the video and then you can check your answers when you're all done. Alright, so you'll notice here on this picture we were missing our radius, so that's a 6, 8, 10 triangle, but Pythagorean theorem will help you solve for that missing piece, the 8. And then pi RL would look like pi times 8 times 10 then, 80 pi for your surface area. Since there is no base volume, we needed to find the area of the base, 64 pi, and then take 1/3 times that 64 pi times the height, and this one is 6, for a total of 128 pi. Okay. Now we're going to take a look at cylinders. Okay, so cylinders, there's no point, so our volume formula just looks like V equals big B times H, area of the base times the height. So again, we're dealing with pi r squared for the area of the base, and then H is going to be on one of the sides. Sometimes they'll draw it through the middle. Okay, so here, we're given the radius, we're given the height. Okay, radius in this case is 5, and the height going on the side is 8. Plugging everything in, we've got pi times 5 squared, which is 25 pi. And then our H, when we plug it in, is 8. Okay, so we just have to take 25 times 8, which is 200. Put that pi on the very end with the label, feet cubed. Okay, for our approximate version, 200 pi is about 628.3 feet cubed. Okay, so these formulas, when we're dealing with the volume of a cylinder, should look a little bit easier than with a cone because we don't have a 1/3 in front to deal with, and most commonly they're going to give you all of the pieces that you need in the picture already. Okay, so the next one, it says it has no top, but again that does not affect volume, so we're doing it the same way that we did this last one. Area of the base times the height. Big B is pi r squared. You'll notice your radius here is 4, so pi times 4 squared. Then 4 squared is 16, so we've got 16 pi. Our height was given on the side here as 10, and we'll put it all together for our final formula. Okay, so the area of the base was 16 pi times our height, which is 10. So we're just taking 16 times 10, or 160 pi, and then label is meters cubed. Okay, so we'll type that in, 160 times pi for our decimal. 502.7 meters cubed. Alright, so these ones go just a little bit faster than those ones up above. Okay, now we're going to add in surface area just like we did with cones. Okay, so on your formula sheet, okay, I want you to look and see what it says for surface area of a cylinder. This time you'll notice that there are two bases in the formula, top and bottom here, and then LA says 2 pi RH. Okay, remember 2 pi r is your circumference of a circle, times the h gets you that rectangle that wraps around. So we need r, we need h, but then we also need b to finish this out. Radius of the circle here is 2. Height of the cylinder is 8. And then area of the base, we've got pi r squared, so we're using that 2. 2 squared is 4. So I've got 4 pi. Base is taken care of. Let's go up here and take care of the lateral area. 2 pi times r times h. The 2 and the pi stay. R is 2 here. And then 8 goes in for h. Okay, so we're taking 2 times 8 is 32 pi. Putting it all together here, we're going to say the lateral area was 32, so 32 pi. And then we're adding 2 of these bases, so 2 times 4 pi. All right. Remember the way you type this in is 32, then plus 2 times 4. And we got 40 with that pi on the very end. Okay, so 40 pi centimeters squared as a decimal. We've got about 125.7. Again, centimeters squared. Volume is area of the base times the height. We've already got the area of the base here, 4 pi. We've already got the height, 8. So we just have to take 4 times 8 is 32 pi centimeters cubed. Again, we take 32 times our pi to get our decimal, about 100.5 centimeters cubed. Okay. On the next one here, it says no bases. That means there's no top, no bottom. So our surface area here, instead of looking like lateral area plus 2 bases, it's just the lateral area. Okay, so I want you to set up lateral area equals, write down your formula, decide what variables go into play, and do the same thing for your volume formula. Okay, set that up. I want you to find surface area and volume. Pause the video. You can check your answers when you're done. Alright, folks, our radius here is 15, height is 10. 2 times pi times 15 times 10 gives you 300 pi. Type it in for the decimal. On the volume here, you didn't have all the information you needed because for the first part, surface area, we didn't have any bases. So we need to find the area of the base first, then we can go ahead and multiply it by that 10, that is our height, for 2,250 pi meters cubed. Okay, go ahead and flip it over and we're going to do some compound shapes. Okay, so surface area and volume of these compound shapes. Surface area, just like we've set it up over and over again. Okay, we're just going to deal with the lateral area of the two shapes and then add the base at the end. Okay, so the first shape is a cone, so we're going to start out with lateral area of the cone. That's our pi RL. So I need the radius and the slant height of the cone. Looking up at the top, the radius is 6, so we're good to go there, but the L is missing, so we need to find time to go ahead and solve for that missing piece. 6 squared plus 8 squared equals x squared. Okay. Hopefully we're getting familiar with some of these Pythagorean triples so that we do not have to solve for x every single time, we just know it. For example, this is a 6, 8, 10 special triangle, but we've got 38 plus 64 gives us 100. Square root of 100 is 10. Okay, so our missing piece, our slant height there is 10. So then we can plug that all in. Pi times 6 times 10. 6 times 10 is 60, so we've got 60 pi. All right, done with the first piece. Second piece, we're going to look at the lateral area of the cylinder. Okay, and that's 2 pi RH. Okay, so we've got R and we've got H. The radius is still 6. The height, we're looking at the cylinder, the height is this 7 down here. So then we've got 2 times pi times 6 times 7. Okay, so we're taking 2 times 6 times 7 is 84 pi. Lastly, we have one base on the very bottom that's on the outside. Okay, both of our bases are circles. It's pi r squared, and that looks like pi times our radius for both of these was 6 there, so 6 squared is 36 pi. Putting it all together, we have to add just those three numbers. Okay, so we're taking our 60 plus 84 plus 36 for a total of 180, but then a label on that is pi. And centimeters squared. Sorry, this label is centimeters squared, but we have to have that pi on there to finish our number. If we multiply by pi, that'll give us our decimal approximation. So that's 565.5. Again, centimeters squared. Volume, we're doing the same thing. We're going to separate it by pieces, but we only really have to worry about the volume. We don't have to worry about whether bases are included or not included. So we've got the volume of the cone first. It's got a point, so it's got 1/3 in front, but area of the base times the height. Big B we already found over here. So 1/3, big B is 36 pi. Now this height is the height of the cone. So over here, we're only looking at the cone. The height going up and down is 8 there. So times 8. Okay, so 1/3 times 36 times 8 for 96 pi. So we'll use that. And then the volume of the cylinder is just area of the base times the height. Okay, so this base stays the same, it's 36 pi, but we're multiplying it by h of the cylinder. The cylinder is 7. Okay, so you'll notice for these two, the h is not the same. So be very careful on that. Alright, but let's go ahead and get that typed in. 36 times 7 gives you 252 pi on the end. With that, we're going to take and add 96 to it for a total volume of 348 pi centimeters cubed. Okay, our decimal, if we multiply that by pi, is 1093.3 centimeters cubed again. Alright. What I want you to do is pause the video for me and attempt number 10 by yourself. Okay, what I will tell you here is just like we had to solve on this last piece for the slant height, you have something missing on this shape as well, but this time it's the radius. Okay, so you'll need that both for surface area and volume, so you'll need to solve for that first. Okay, pause the video, set up your formulas, and see if you can find both the surface area and the volume for me. Okay, so your x here in this case, when you solve for that missing piece, should have been 20. Okay, so your radius is 20 here. Lateral area of the cylinder, 800 pi, of the cone, 580 pi, area of the base is 400. Put it all together to get 1780 pi. With your volume here, again, you have to pay attention. The h is different in this formula. Okay, so the cylinder looks like 8,000 pi. The cone looks like 2,800 pi. Putting it all together, you got 10,800 pi meters cubed for that total volume. Okay, if you made a mistake and these answers don't match, just pause the video and see if you can go through here to match up your variables with mine. Okay. Our last problem is just an application of what we learned today with volume. It says, the part of a dish designed for ice cream is shaped like an upside down cone. The base of the cone has a radius of 2 inches and the height is 1.2 inches. We want to know how many cubic inches of ice cream can the dish hold. Okay, so two things indicate what we're trying to solve for here. It says cubic inches and it says hold. Okay, cubic inches is the label for volume. When it says hold, that means on the inside, and that also indicates volume. So we've got this cone shape, so we're using the V equals 1/3 area of the base times the height. And our area of the base is pi r squared. Okay, so we're looking for where it told us the radius in here. Okay, you'll notice it says radius is 2 inches. If it helps you to put it on the picture here, you absolutely can. So we've got 2 inches for r. So that's pi times 2 squared, or 4 pi. Then we also need the height of the cone, and it says that's 1.2. So it's saying it's 1.2 inches deep there. Alright, putting it all together, we've got 1/3 times our big B, area of the base was 4 pi, and our height was 1.2. Okay, so we've got 1/3 times 4 times 1.2, so that's 1.6 pi cubic inches, or inches cubed. For word problems, we're more familiar with working with this in terms of measuring ice cream. Okay, it's a little strange to deal with pi numbers. Okay, so this is an application where it's actually nicer to have the decimal version of the answer. Okay, so when we multiply by pi here, we get approximately 5 inches cubed of ice cream. And that's it. Alright, if you have questions while you're doing your homework, please feel free to come see me.